AM, Emperor's Advanced Mathematics. This morning I'm going to be solving more questions for you on implicit function. So I want you to sit tight, enjoy yourself. God bless you. Let me see, we're having x squared y plus x equal to 4. Is the question given? From our previous knowledge, we all understood that changes in x will be taken with respect to y, and y also with respect to x, respectively. Looking at this one very well, we're having x squared y plus x is going to give us 4. Now we shall find the y dx. That is differentiation. We want to find the y dx. That is the derivative of this expression. Okay, this is an implicit function. Do not forget. Anywhere they ask you to differentiate two variables with respect to one another, that is called an implicit function. Alright, I want to differentiate x with respect to y. That will be 2 times x raised to the power 2 minus 1. Because the 2 is the power multiplied by the coefficient, invisible one. That's it. Subtract 1 from it using general method. Put that y beside it. It means you have differentiated x with respect to y. Now plus, you are going to be writing x alone now, then you differentiate y. That will be x squared is standing times 1 is the power, invisible one. Invisible one. So multiply by y, 1 minus 1. Because the 1 is subtract 1 from it also. Since we have differentiated both x and y, then we are going to put the y dx. Plus, remain this one out. This one is having only x. It's not having y. Alright, so I'm going to be having plus x raised to the power 1 minus 1. Times 1 does not actually mean anything. So we're going to be having equal to 0. It's 4 that is there. Right? So we're having equal to 0. Now since we're having equal to 0, I'm going to be solving from this length. So I'm going to be having 2 times x. 2 minus 1 is raised to the power 1, so invisible 1. Let me clean it up. So I'm having y plus x squared times 1 dy dx plus x raised to the power 0. It's going to give me 0. So therefore I'm going to be having 2 times xy. That will be 2xy plus x squared times 1 dy dx. That will be x squared dy dx plus 1 equal to 0. Now I want to make this one the subject now. That will be x squared dy dx is going to be giving me 0 minus 2xy minus 1. So I'm going to be having x squared dy dx is going to be minus 2xy minus 1 over and over x squared over x squared. This cancel this. So I'm going to be having the y dx is going to be minus 2xy minus 1 over x squared. That is my final answer for this differentiation. Thank you so much. Thank you so much. You can see it on the board. You can see it on the board. Alright, let's do one more example of this before we go to the next frame. Given x squared y plus y squared x squared plus 3x minus 1 equal to 0. And the y dx equal to 2 when x equal to 2. Find y, then find y. We want to find the value of y. This question is something similar to jam question, and sometimes it's y question. Now we're going to solve it. It's very simple. Just sit tight and enjoy yourself. Thank you. So I'm going to be having x squared, differentiating it as usual. That will be 2x, 2 minus 1, minus 1. Y will be beside it, plus. Now I've differentiated x. I'll write x squared again, differentiate y. That will be times 1 times y, 1 minus 1. Since I've differentiated y, I have to put the y dx. Alright. Now, I'm going to be having plus. I'm through with this side. Remain this one now. I want to differentiate y first here. That will be giving me 2y raised to the power 2 minus 1 x squared y, dx. The question you'll be asking me now is why do I have to put the y, dx direct? I am only doing that because y come first, and you know we should differentiate y with respect to x, but near y come first, so if y come first, we first put the y dx. Now I want to differentiate x with respect to y. Let me continue from down part because of that place. I don't want the work to be too rough. Or I want to continue from the right part, from down here. Okay. Therefore, since I've differentiated y already, I want to differentiate x. That will be y squared. X squared is what I want to differentiate now. So I'm going to be having times 2, which is the power x is power 2 minus 1. I will not put the y dx again because I've already put it here. So I've differentiated the 2 now. Plus 3 times x raised to power 1 minus 1 minus 0 equal to 0. This one is a constant value, tends to 0 immediately. So I'm going to be having 2x raised to power 1, that's 2xy, plus x squared times 1, anything raised by 0 is 1, that's times 1 times 1, that will be the y dx, plus 2y x squared dy dx, okay, plus this one is 2x, when you multiply it, that will be 2xy squared, 2xy squared, plus 3x raised to power 0, which is still the same thing as 3 times 1, that's 3, equal to 0. The question you should ask me now is that when I go to this place, I didn't put the y ds. Yes, because I am differentiating only x. I am not differentiating it with respect to any y. So that is just the reason there. Now what am I going to do? I want to collect all the y dx together. So I'm going to be having x squared dy dx plus 2yx squared dy dx. It's going to be giving me, all this one will go to the other side, minus 2xy, that's first one. Alright, after that one I am having second one, that's minus 2xy squared, and the last one, minus 3. Okay, now I want to factorize from this edge. The y ds is common, I want to bring it out. I'm going to be having x squared plus 2yx squared. Close the bracket and open it, that's the y dx. It's going to be giving me, minus is common, minus open bracket 2xy minus 2xy squared minus 3. Close it. So I'm going to be dividing both sides. Okay, so we turn to plus, since I've already brought out the minus. So that's plus plus. Okay, so divide both sides by x squared plus 2yx squared. Also, this one also will be x squared plus 2yx squared. This cancel this. So I'm going to be having the y dx is going to be giving me minus open bracket 2xy plus 2xy squared plus 3 close over x squared plus 2yx squared. That is what I am having as my result. But looking at it very well, we discover that from the question here they said and dy dx equal to 2. So it means the answer I'm having for my dy dx down here, dy dx, this answer will definitely become 2. So let's change it now. When x equal to 2 also. So anywhere I see x, I change it to 2. And anywhere I see the y dx, I change it to 2 also. So I'm going to be having that dy dx is going to be 2. And also x also equal to 2. That is what I am having. Alright. I'm going to be having 2 equal to minus open bracket 2xy plus 2xy squared plus 3 over x squared plus 2yx squared. Alright, so that's what I am having. So let me say this one is already the y there, that's 2. So anywhere I see x also I change this to 2. So I'm going to be having bracket 2 here. Alright, I'm going to be having bracket 2 here. Alright, I'm going to be having bracket 2 here. Alright, and this place I'm going to be having bracket 2. That's what I'm having. So therefore I'm going to be having 2 equal to minus open bracket 2 times 2, that's 4y plus 4y squared plus 3 over 2, that's 2 squared, that's 4. 4 plus this one is 4, 2 times 2 is 4, that will be 8. That will be 8y. Alright, that's what I'm having as my denominator. I can put this one over 1. Alright, after that I want to cross multiply. So therefore I'm going to be multiplying 2 bracket 4 plus 8y is going to be giving me minus open bracket 4y plus 4y squared plus 3. This is it. Looking at this question very well, it's already going towards something like quadratic equation. You can see all from here is an implicit function, just normal implicit function. And from all the solutions, you can see it down to this place. You can see what we're having here as our derivative of this question up here. Alright, but looking at the question very well again now, the question is leading us to another thing entirely. But let's try our best. Let's expand this minus out so as to ease the whole work. 2 times 4 is 8 plus 2 times 0 is 16y is going to be giving me minus 4y squared minus 3. Now I'm going to be collecting like terms. Let me see what I can do towards that. So let me bring this one to this side and bring it to this side. That will be minus 4y squared minus 4y, okay, minus 3 is going to be 8 plus 16y. I didn't change anything there. I only carry this one to this side and carry this one to this side just to ease my work. I'm going to be having minus 4y squared minus 4y, okay, let me say minus 16y, okay, minus 16y when this one cross equal to 8. This one will change to, or let me bring anything to this side. That's minus 3 minus 8 is going to give me 0. So I'm going to be having minus 4y squared minus 16 plus, that's minus 20y minus 8 plus 3. 8 plus 8, that will be 11. So I'm going to be minus 11 equal to 0. So I'm going to be having this. But minus is common for everything, so I can easily factorize it out. That's minus open bracket 4y squared minus 20y minus 11. Since minus already outside, all this one changed to plus equal to 0. Now, divide both sides by minus 1, divide by minus 1. This cancels this. So I'm having 4y squared plus 20y plus 11 is going to be giving me 0. You can see now, it's already a quadratic equation. Now I'm going to be solving it quadratically. But because of my time, I'm not going to be using any complex method, but I'm going to be making use of just quadratic formula, which some people call it almighty formula. Let's see what we can do. I'm going to do that here. So let me say using formula, using quadratic formula. Alright. The formula is x equal to minus b plus or minus square root b squared minus 4ac over 2a. So therefore I'm going to be having a equal to the first value there, which is the coefficient of your y squared. That will be 4. 4. A is 4. Comma. And b is the coefficient of your y. That will be 20. So b equal to 20. And c is 11. C is 11. So c equal to 11. Alright. Now there's something I need to do here. The question, I am not looking for x. On the further, let's look at the question here. We are having 4y squared. It means we are looking for the value of y, not the value of x. So I'm going to be changing this thing to y. So automatically I want to change this to y. So I'm going to be having y equal to. Thank you for that. Alright. I'm going to be having y equal to minus 20, because b is 20, plus or minus square root 20 square minus 4 times a is 4 times 11. So that will be giving me over 2 times 4. So I'm going to be having this, right? we're going to be having y equal to minus 20 plus or minus square root 400 minus 176, which is the product of all this one over 8. So I'm going to be having y equal to minus 20 plus or minus square root of 400 minus 178. That's 400, 178. So I'm going to, okay, 176. So that will be, going to be borrowing 1 from here. This one will remain 39. So I'm going to be having 4. So I'm going to be surprised one, that will be 2. So this one remain 3. That will be 2 also. 2, 2, 4. I'm going to be having 2, 2, 4 over 8. So right. So I'm going to be having square root of this, which is going to be y. It's going to be giving me minus 20 plus or minus. Square root of this is 14.97, which is approximately to 2 decimal places. So over 8. So I'm having y equal to minus 20 plus 14.97 over 8, or minus 20 plus 14.97 over 8. This one will be minus. First one is plus. So that's minus. So I want to be adding it now. That's minus 20. That will be 14.97 minus 20. That will give me this. So divided by 8, it give me this. That will be 0.63. That's minus 0.63. Okay. So or this one minus minus. That will be 20 plus 14.97. So I'm going to be having this. That will be 34.97 divided by 8. So that will be giving me, divided by 8, that will give me 4.37 minus. So that's my answer. So my answer is either minus 0.63 or minus this. So which is equal to value of y. That's the value of y. You can see how very long the question is. Let's peruse it again right from the beginning. From here. Now I want to peruse it. Look at it from beginning. Alright. To this level. Then we go. You can see from here again. You can see. You can see. You can see. Alright. This is where the thing turns to quadratic equation. You can see it. And also from here using formula. Then we solve to the end of everything. Thank you so much.